Now, today we discuss lens maker's formula and focal length for different lenses and also focal power. Now, first of all, lens maker's formula. What is lens maker's formula? Here it gives it is related to focal length of a lens and refractive index and radii of curvatures of the lens. Now, lens maker's formula. Here, what is formula for focal length? 1 by f is equal to what? Mu minus 1. Here, mu lens by mu medium minus 1 into 1 by R1 minus 1 by R2. Here, what is f? F represents what? Focal length of a lens, mu L, refractive index of a lens, mu M, refractive index of a medium, R1, R2 are radii of curvatures of a lens. Now, you know that radius of curvature. Here, F represents what? Focal length of a lens. Suppose, what are R1, R2 radius of curvatures? Now, suppose if the lens is placed in air vacuum. In air vacuum, mu medium how much? For air medium, mu M how much? 1. Now, if a lens is placed in air vacuum, mu L minus 1, mu L by 1, mu L only, mu L minus 1 into 1 by R1 minus 1 by R2. This is the formula for focal length of a lens. And also you know formula for lens formula. What is lens formula? 1 by f is equal to what? 1 by v minus 1 by u. What is u here? Object distance. What is v? Image distance. What is f? Focal length. Here you know convention. Here we are calculating distances. Distances measured in the direction of incident rays are taken as what? Positive. If we calculate distances measured in opposite direction are taken as what? Negative. So anyhow, here focal length of a lens. Focal length of a lens 1 by f is equal to what? Mu L minus 1 into 1 by R1 minus 1 by R2. What is mu L? Focal refractive index. Refractive index of a lens. Here, otherwise, if the lens is placed in medium, on the time we are taking this formula. What is formula for focal length? 1 by f is equal to what? Mu L by mu M minus 1 into 1 by R1 minus 1 by R2. Here, what is mu L? Focal length of a lens. What is mu M? Mu L represents what? Refractive index of a lens. Mu M represents what? Refractive index of a medium. Refractive index of a medium. Now, these R1, R2 values. R1, R2 values are now different, sometimes positive, sometimes negative. Suppose in case of convex lens. In case of convex lens, here, now you remember this formula. What is F? F represents focal length. Now, for convex lens, like this, convex lens, double convex lens. Now, R1, this is R1, now this is R2, like this. You know that lens is a part of a sphere. Now, here for, okay, R1, here for a convex lens, here R1 is positive, here R2 is negative. Why? If the object is placed here, we are getting light rays like this. Object here distances measured in the direction of incident rays are taken as what? Positive. Now this is the optic center. Now, so here this is R1. So R1 is positive, R2 is negative. Here distances measured in the direction of incident rays are taken as positive. Light rays are from left to right side. So R1 is positive, here R2 is negative. That is why here for convex lens, double convex lens how much? 1 by f is equal to what? Mu L minus 1 into 1 by R1 minus of minus 1 by R2. Why minus 1 by R2? R2 is here for double convex lens, R1 is positive. R1 is positive, R2 is negative. R2 is negative. So focal length becomes what? 1 by f is equal to what? Mu L minus 1 into 1 by R1 minus of minus 1 by R2. So 1 by f is equal to mu L minus 1 into 1 by R1 minus of minus plus 1 by R2. This is formula for focal length of a double convex lens. What is that formula? 1 by f is equal to mu L minus 1 into 1 by R1 plus 1 by R2. 1 by R1 plus 1 by R2. Equiconvex lens R1 is equal to R2 is equal to how much? R. Focal length becomes what? 1 by f is equal to what? Mu L minus 1 into 1 by R plus 1 by R. So we are getting 1 by f is equal to how much? Mu L minus 1 into 2 by R. This is formula for focal length of a equiconvex lens. Equiconvex lens. For equiconvex lens, R1 is equal to R2 is equal to how much? R. Now, so it depends on these formulas we have problems. And next one, here, concave lens. This is for convex. What is the formula for focal length of a convex lens? 1 by f is equal to what? Mu L minus 1 into 1 by R1 plus 1 by R2. Equiconvex lens, 1 by f is equal to how much? Mu L minus 1 into 2 by R. What is R? Radius of curvature. Radius of curvature. In examination, they will give sometimes R1, R2, mu L find focal length. Otherwise, they are giving focal length, mu L find the radius of curvature. Radius of curvature. Like that. This is concave. Now, this is R1. Now, this is R2. Like this. Here, you know, formula for according to lens maker's formula. According to lens maker's formula, what is formula for focal length? 1 by f is equal to how much? 1 by f is equal to mu L minus 1 into 1 by R1 minus 1 by R2. For concave lens, here R1 is negative. R1 is negative. R2 is positive. So, what we are getting now? 1 by f is equal to mu L minus 1. Here why R1 is negative? We measure distances. We measure distances in the direction of incident rays are taken as positive. But opposite direction, we are getting light rays here. Now we measure R1 opposite direction of incident rays. So R1 is negative, R2 is positive. So how much here? Here 1 by f is equal to mu L minus 1 into minus 1 by R1 minus 1 by R2. So we are getting 1 by f is equal to minus of, we take minus common, mu L minus 1 into 1 by R1 plus 1 by R2. 1 by R1 plus 1 by R2. What is difference? For convex lens, what I told formula? 1 by f is equal to what? Mu L minus 1 into 1 by R1 plus 1 by R2. For concave lens how much? 1 by f is equal to minus of mu L minus 1 into 1 by R1 plus 1 by R2. 1 by R1 plus 1 by R2. Like that. Now, for R1, here R1 is positive, R2 is infinity. For plano-convex lens, it is plano-convex lens. Here R1 is positive, R2 becomes how much? Infinity. It is plane. Now that's why here focal length becomes what? 1 by f is equal to what? Mu L minus 1 into 1 by R1 how much? Here let it be R. Let R1 is equal to R. Now 1 by R minus 1 by infinity. Something by infinity how much? 0. So 1 by f is equal to mu L minus 1 into 1 by R minus 0. From this 1 by f is equal to how much? Mu L minus 1 into mu L minus 1 by R. Here focal length of plano-convex lens. Focal length of plano-convex lens how much? Mu L minus 1 by R. What is R? R be the radius of curvature. What is this? This is the focal length of a concave lens. Focal length of a concave lens is 1 by f is equal to what? Minus of mu L minus 1 into 1 by R1 plus 1 by R2. Mu L minus 1 into 1 by R1 minus 1 by R2, like this. Here for a given lens, R1, R2 are constants. What are R1, R2? R1, R2 are the radii of curvatures. Now, from this, for a given lens, R1, R2 are constants. So, on the time, here R1, R2 are constants. What we are getting? 1 by F proportional to mu L minus 1. 1 by F proportional to how much? Mu L minus 1. If the refractive index is more, focal length is less. Refractive index is less, focal length is more. Inversely proportional. Here F proportional to, what we read now? F proportional to 1 by mu L minus 1. What is mu L? Mu L is the refractive index of a lens. Here refractive index of a lens is less, focal length is more. Inversely proportional. Refractive index is more, focal length is less. Focal length is less. Now, next one. Here suppose if the lens is immersed in a liquid, and also now before that here now, so anyhow focal length is inversely proportional to what? Refractive index of a lens. And enti ikkada focal length ఈ రిఫ్రాక్టివ్ ఇండెక్స్ కి ఇన్వర్స్లీ ప్రపోర్షనల్ గా ఉంటుంది. ఏంటి? వక్రీభవన గుణకానికి ఈ ఫోకాల్ లెంత్ ఇన్వర్స్లీ ప్రపోర్షనల్ గా ఉంటుంది. వక్రీభవన గుణకం తక్కువ ఉంటే ఫోకాల్ లెంత్ ఎక్కువగా ఉంటుంది. వక్రీభవన గుణకం ఎక్కువ ఉంటే వక్రీభవన గుణకం తక్కువ ఉంటే ఫోకాల్ లెంత్ ఎక్కువగా ఉంటుంది. వక్రీభవన గుణకం ఎక్కువ ఉంటే ఫోకాల్ లెంత్ తక్కువగా ఉంటుంది. ఇన్వర్స్లీ ప్రపోర్షనల్. Now suppose if the lens is immersed in a liquid, now if the lens is placed in air, what is formula? 1 by F air. 1 by F air is equal to how much? Mu L minus 1 into 1 by R1 minus 1 by R2. If the lens is immersed in a liquid, if the lens is placed in air or vacuum, 1 by F is equal to what? Focal length of a lens in air how much? Mu L minus 1 into 1 by R1 minus 1 by R2. Mu L means what? Mu lens, like that. Now, if the lens is immersed in a liquid, on the time 1 by focal length of a lens in a liquid, it becomes what? Mu lens by mu liquid minus 1 into 1 by R1 minus 1 by R2, like that. So, on the time here, now this is first equation, this is second equation. What is this? Change in focal length of a lens when it is immersed in a liquid. Now, first equation divided with second equation. What we are getting now? First equation 1 by F in air by 1 by F in liquid. How much now? Here what we are getting? Mu lens minus 1 into 1 by R1 minus 1 by R2 by here mu lens by mu liquid minus 1 into 1 by R1 minus 1 by R2. From this, here 1 by R1 minus 1 by R1, 1 by R1 minus 1 by R2, 1 by R1 minus 1 by R2 gets cancelled. So, what we are getting now? 1 by F air by 1 by F liquid. So, we are getting 1 by F air into F liquid by 1. F liquid by 1 is equal to, we got mu lens minus 1 by mu lens by mu liquid minus 1. So, we are getting like this. F liquid by F air. F liquid by F air is equal to mu lens minus 1 by mu lens by mu liquid minus 1, like this. Here focal length value changes. If the lens is immersed in a liquid, in general what is formula of focal length of a lens in air? 1 by F air is equal to what? Mu lens minus 1 by into 1 by R1 minus 1 by R2. But if it is immersed in a liquid, what happened? A refractive index value changes, mu lens by mu liquid. Here also we are taking refractive index of air or vacuum, how much? 1. Now, but refractive index of liquid. So, if lens is immersed in a liquid, so 1 by F liquid is equal to what we are getting? Mu lens by mu liquid minus 1 into 1 by R1 minus 1 by R2. Now, dividing equation 1 by 2, we got like this. F liquid by F air is equal to what? Mu lens minus 1 by mu lens by mu liquid minus 1. Now, here we have 3 cases. Now, first of all, if the refractive index of a lens is greater than refractive index of a liquid, is it clear first of all of you? What is this? Change in focal length when it is immersed in a liquid. మనం ఇక్కడ లెన్స్ ని ఒక లిక్విడ్ లో మనం డిప్ చేస్తున్నాం, అప్పుడు ఫోకల్ లెంత్ వాల్యూ చేంజ్ అవుతుంది. ఆ ఫోకల్ లెంత్ వాల్యూ ఎంత అవుతుంది? ఫోకల్ లెంత్ ఆఫ్ ఏ లిక్విడ్, ఫోకల్ లెంత్ ఆఫ్ ఏ లెన్స్ ఇన్ ఏ లిక్విడ్ is equal to what? Focal length of a liquid in a lens is equal to F liquid is equal to F air into mu lens minus 1 by mu lens by mu liquid minus 1, like that. Focal length value changes. We have 3 cases. First case, here F liquid is equal to focal length of lens in a liquid is equal to what? FA by mu lens minus 1 by, here mu lens is greater than mu liquid. So, mu lens by mu liquid. It is greater, mu lens is greater than mu liquid. So, we are getting positive value. So, denominator becomes what? Less. So, focal length of a liquid is greater than focal length of a lens in air. Here focal length value increases. There is no change in the nature of the lens. So, we take convex lens only, but focal length value increases. So, focal power decreases. I explained focal power also. Anyhow, if the lens is immersed in a liquid of a lesser refractive index, here focal length of a lens is greater than, if a lens is immersed in a liquid of lesser refractive index, mu lens is greater than mu liquid. So, focal length of a liquid is greater than focal length of a lens in air. Now, there is no change in the nature of the lens, but focal length increases. What happened here? Focal length increases like that. Otherwise, case 2, mu lens is less than mu liquid. So, this denominator becomes what? It is negative. Here suppose it is mu lens is 5, here mu lens is 6, mu lens is less than, here mu lens is less than mu liquid. Now, suppose if you take 4 by 5, mu lens is 0.4, mu liquid is, suppose mu lens is 4, mu liquid is 5, 4 by 5 how much? 0.8 minus 1, minus. We are getting minus. Focal length of a lens in liquid becomes minus of focal length in a liquid. Focal length of a lens, mu lens minus 1 by mu lens by mu liquid. Here what happened? We are getting negative value. If the lens is immersed in a lesser refractive index, here mu lens is greater than mu liquid. Here focal length, if the lens is immersed in a liquid of lesser refractive index, on that time there is no change in the nature of the lens, focal length increases. But if the lens is immersed in a liquid of greater refractive index, mu lens is less than mu liquid, means what? A lens is immersed in a liquid of greater refractive index. Here liquid of lesser refractive index. Here liquid of what? Greater refractive index. On the time here focal length becomes negative. We take convex, here FA is positive, but F liquid is negative. Means what? Nature of the lens changes. If you take convex lens, it becomes concave. If you take convex lens, if the convex lens is immersed in a liquid of lesser refractive index, liquid of, here it is greater, it is, if the lens is, here mu lens is greater than mu liquid, here liquid refractive index is less, here liquid refractive index is more. If the lens is immersed in a liquid of what? Greater refractive index. If a lens is immersed in a liquid of greater refractive index, nature of the lens changes. Nature of the lens changes. Nature of the lens changes means what? If you take convex lens, it becomes concave. If you take concave, it becomes convex, like that. When? If it is immersed in a liquid of greater refractive index. Already lens having some refractive index, if it is directly, if it is immersed in a liquid of greater refractive index, on that time nature of the lens changes. Nature of the lens changes. How we decide? It becomes, if you take positive focal length lens, it becomes negative. If you take negative focal length becomes what? If it is immersed, it becomes positive. So convex becomes concave, otherwise concave becomes what? Convex, like that. This is case 2. Here it becomes what? Focal length of a lens in a liquid becomes air mu lens minus 1. Here both are equal, mu lens by mu liquid. So this becomes 1. 1 minus 1 how much? 0. F air into mu lens minus 1 by 0. Something by 0 how much? Infinity. Something by 0 how much? Infinity. It becomes plain glass plate. If it is immersed in if a lens is immersed in a liquid of equal refractive index, if a lens is immersed in a liquid of equal refractive index, on that time it becomes plain glass plate, like that. We have 3 cases. In problems, first you check the refractive index. Here liquid refractive index you compare with the lens refractive index. If it is equal, it becomes plain glass plate. If it is greater than refractive of lens, it becomes, nature of the lens changes. Otherwise, if the focal length of a lens is greater than refractive index of a lens is greater than refractive index of a liquid, on that time focal length value increases. So there is no change in the nature of the lens, like that. Here focal power. Suppose a beam of light incident, here unit distance from the principal axis. Now like this, it converges here. Now this angle is called what? Here tangent of angle. Focal power of a lens is defined as the tangent of the angle by which it converges or diverges. Here a beam of light incident at unit distance from the principal axis. Now this is principal axis. Now this is H, like this. Now tan delta is equal to how much? Tan delta is equal to H by F. Tan delta is equal to what? Opposite side by adjacent side. What is this? This is adjacent side, F. Now opposite side by adjacent side. Now, so it is called what? Focal power. Here focal power is represented by what? P. Is it clear? What is definition? Focal power of a lens is defined as the tangent of the angle by which it converges or diverges when a beam of light incident at unit distance from the principal axis. Now this is the beam of light. This is the beam of light. Now beam of light incident on the lens, unit distance from the principal axis. So H is equal to 1 meter, unit distance. So on the time here focal power P is equal to tan delta is equal to 1 by F. Now, so reciprocal of focal length. Reciprocal of focal length. P is equal to what? 1 by F. What is unit of focal length? Meters. So meter inverse. Meter inverse is equal to what? diopter. Meter inverse is called what? Diopter. Now, if you take like this, here 1 by f, if we are calculating focal length in meters, unit of focal power is diopters. Now, otherwise, if you take focal length in centimeters, now here if we are taking focal length in centimeters, 1 centimeter is equal to how many meters? 10 power minus 2 meters. So, we are getting here 10 power minus 2 meters. So, we are getting 100 by f diopters. Diopter. Here, what is formula for focal length? Here, focal power is equal to 1 by f. Focal power is equal to what? 1 by f diopters. Otherwise, here f means what? F is in meters. Otherwise, we have focal length in centimeters. How we calculate focal power? Focal power is equal to 100 by f diopters. If the lens is made up of 3 or 4 materials, suppose we have a lens like this. Here, if a lens is made of 4 materials, if a lens is made of what? 4 materials, we have like this. This is one material, this is second material. Now, we have one more material like this, and this is fourth material. Now, 1, 2, 3, 4. If a lens is made of 4 materials, all the time we are getting 4 images. Why? Here 1 by f is equal to what by formula? Mu minus 1 into 1 by r1 minus 1 by r2. Here refract index is different. Refract index value is different. So, mu value is different for different materials. How many materials we have? 1, 2, 3, 4. Mu 1, mu 2, mu 3, mu 4. Like that, here 1 by f proportional to how much? Mu minus 1. So, mu values are, we have 4 mu values, so we are getting 4 focal lengths. Cutting of a lens. If a lens is cut along the principal axis, like this. So, on the time we have, this is one lens, this is one lens. If a lens is cut along the principal axis, this is one lens, this is one more lens. On that time, suppose, what is the focal length of equiconvex lens? Focal length of equiconvex lens, what is formula? 1 by f is equal to mu minus 1 into 2 by r. If a lens is cut into, if a equiconvex lens is cut along the principal axis, we are getting two lenses. On the time, there is no change in the refractive index. Here, there is no change in refractive index and radius of curvature. So, there is no change in mu value and r value. So, there is no change in the focal length, but intensity will change, decreases. Intensity will be reduced. Here, if the lens is cut along the principal axis into two equal parts, what happened? Here, focal length, there is no change in the focal length, but intensity reduced to half, like that. Otherwise, is it clear now? If the lens is cut along the principal axis, there is no change in the mu value and r value. There is no change in the value of mu value and r value. That is why there is no change in the focal length, but intensity value reduced to what? Half. Otherwise, if the lens is cut perpendicular to principal axis, you take a equiconvex lens, it is cut into two equal parts perpendicular to, transverse to principal axis, like this. On the time, we are getting two pieces. This is one lens, again we are getting this is one more lens. it is cut into two equal parts. All the time here 1 by f is equal to what? Mu minus 1 into 2 by r. 1 by f is equal to what? Mu minus 1 into 2 by r. Now it is plano-convex lens. It is plano-convex lens. What is formula? It is plano-convex lens. For plano-convex lens, 1 by f dash. 1 by f dash how much? Mu minus 1 into 1 by r. Mu minus 1 into 1 by r. So now, here what we write now? F dash is equal to what we write? Here, f dash, here we substitute now. 1 by f is equal to 2 into, here, what 2 into f dash. Now f dash becomes what? F dash is 2f. Focal length of each part becomes what? Twice the focal length of original lens. F dash becomes what? Twice. Focal length becomes twice. Focal power becomes what? Half. Here focal power P dash is equal to what? 1 by f dash. So 1 by 2f. So P by 2. Focal power becomes P by 2. Focal length becomes what? 2f. When if a equiconvex lens cut transverse to principal axis, perpendicular to principal axis, so on that time focal length of each part becomes 2f, focal power becomes what? Half of the focal power of original lens. Focal power becomes what? Half of the focal power of original lens. Like combination of lenses. Here suppose if two lenses are in contact, we consider two thin convex lenses. Two thin convex lenses of focal lengths f1 and f2 are in contact like this, f1 and f2. Here these two convex lenses having focal lengths how much? f1 and f2. Now these are thin lenses. Now both are optic center at P only. On the time, suppose if the object is placed at O at a distance u from P, here first of all object is placed behind the first lens AB. Object is placed at a distance u from the at a distance u behind the first lens A, behind the focal plane of lens A. On that time this object acts here on the time first lens, here image formation is takes place in two steps. First of all, first lens forms the image at I1. This image acts as this real image acts as the virtual object for the second lens. Here first lens forms the image at I1. Now this real image acts as virtual object for second lens. Now this finally this image is formed at V at a distance V from P. On the time here this distance is V dash I1. Here first of all first lens forms the image I1 at V dash from P. Now this image, this real image acts as object for, this real image acts as virtual object for the second lens. So final image is formed at a distance V. Here final image is at O dash. Otherwise we take I. This is the I. Now where is this? At a distance V. Now for first lens how much what we write now? 1 by V dash. 1 by V dash minus 1 by U is equal to what? 1 by F1. This is first equation. For second lens, according to lens formula, what we write? 1 by V dash minus 1 by U is equal to what? 1 by F1. Again second one. For second one, we are getting 1 by V minus 1 by V dash is equal to what? 1 by F2. Now adding equations 1 and 2, 1 plus 2, what we are getting now? What is first equation? 1 by V dash minus 1 by U plus 1 by V minus 1 by V dash is equal to 1 by F1 plus 1 by F2. From this, here plus 1 by V dash minus 1 by V dash. Now what we are getting? Here 1 by V minus 1 by U is equal to 1 by F1 plus 1 by F2. Now here combination of two lenses is treated as a single lens. Now F be the focal length of single lens. So on the time, what we are getting now? Here 1 by F is equal to 1 by F1 plus 1 by F2, like this. If two lenses are in contact, on the time there is no separation here. Two lenses are in contact. Focal length of combination how much? 1 by F is equal to what? 1 by F1 plus 1 by F2. 1 by F1 plus 1 by F2. But reciprocal of focal length is called what? Focal power. Now two lenses are in contact. So what we are getting now? P is equal to what? P1 plus P2. P is equal to how much? P1 plus P2, like that. If two lenses are in contact, what is focal length? Effective focal length 1 by F is equal to 1 by F1 plus 1 by F2. And in the same way, focal power is equal to what? P1 plus P2. P is equal to how much? P1 plus P2. Otherwise, now these two lenses are separated by a distance d. Number of lenses are in contact. What we write? Here not only two, we have more number of lenses are in contact. So 1 by F is equal to what we write? 1 by F1 plus 1 by F2 plus 1 by F3 and so on, like that. In the same way, focal power P is equal to how much? P1 plus P2 plus P3 and so on, like that. If number of lenses are in contact, focal length becomes how much? Effective focal length how much? 1 by F is equal to 1 by F1 plus 1 by F2 plus 1 by F3 and so on. Focal power how much? P is equal to what? P1 plus P2 plus P3 and so on, like that. Otherwise, two lenses are separated by a distance d. Two lenses are separated by a distance d. On the time, here focal length, effective focal length is equal to, here we have formula 1 by F. Two lenses are separated by a distance d, like this. Now d is the distance between two lenses. D is the distance between two lenses. On the time, focal length, here 1 by F is equal to 1 by F1 plus 1 by F2 minus d by F1 F2. Here two lenses are in contact, two lenses are separated by distance d. 1 by F is equal to how much? 1 by F1 plus 1 by F2 minus d by F1 F2. So focal power becomes what? Reciprocal of focal length is focal power. So P is equal to P1 plus P2 minus d into P1 P2, like that. Now when we are using this formula, if two lenses are in contact, there is no separation between the lenses. What we take formula? 1 by F is equal to 1 by F1 plus 1 by F2 plus 1 by F3 and so on. Focal power becomes what? P is equal to what? P1 plus P2 plus P3 and so on. But two lenses are separated by a distance d. Now effective focal length 1 by F is equal to what? 1 by F1 plus 1 by F2 minus d by F1 F2. In the same way, focal power is equal to what? P1 plus P2 minus d P1 P2. What is d? Distance between the two lenses. Distance between the two lenses. Now here we have one special case. Suppose a parallel beam of light incident on the first lens. Again we are getting here finally second lens also forms the again we are getting parallel beam of light. Again we are getting parallel beam of light. All the time F becomes what? Infinity. Here parallel beam of light incident on the combination of lenses. Again we are getting parallel beam. So F becomes what? Infinity. And combination also produces parallel beam of light. So F becomes what? Infinity. So we are getting 1 by infinity. 1 by infinity is equal to what? 1 by F1 plus 1 by F2 minus d by F1 F2, like that. 1 by infinity how much? 1 by infinity is 0. 1 by infinity is 0. From this, here 1 by F1 plus 1 by F2 minus d by F1 F2 is 1 by infinity how much? 0. From this, here 1 by F1 plus 1 by F2 is equal to d by f1 f2, d by f1 f2. Here we take LCM f1 f2, we are getting f2 plus f1 is equal to d by f1 f2. So f1 f2 gets cancelled. We are getting distance between the lenses, d is equal to how much? f1 plus f2. If two lenses, here distance between the lenses is equal to what? f1 plus f2. When we are taking this formula, parallel beam of light incident on the combination, again this combination also produces parallel beam of light on the time. Effective focal power how much? Infinity. 1 by infinity how much? 0. So distance between the lenses how much? f1 plus f2. Suppose in case of, here both are convex lenses, focal power, focal lengths are positive. So we take f1 plus f2. Otherwise, instead of that, one is convex lens, one is concave lens. F1 is first lens is convex, second one is concave. For concave lens, focal length is negative. So what we are getting all the time? D is equal to f1 minus f2. D is equal to how much? f1 minus f2. When we take f1 minus f2, one lens is in this combination of lenses, one lens is convex, one lens is concave. D value how much? f1 minus f2. D value f1 minus f2, both are convex, D is equal to what? f1 plus f2. Is it clear? In problem they mention, how they mention? Parallel beam of light incident on the combination. Again combination produces what? Parallel beam of light. So parallel beam of light means what? Here image is at here focal length becomes what? Infinity. So distance between the lenses is how much? f1 plus f2. A glass convex lens, a glass convex lens of refractive index, convex lens of refractive index 3 by 2 as focal length, 3 by 2 as focal length equal to 0.3 meters, Now find the focal length of a lens if it is immersed in a water of refractive index 4 by 3. Find the focal length of a lens, if it is immersed in a water of refractive index, 4 by 3. Now we have question, what is that? A glass convex lens of refractive index, 3 by 2. So refractive index of lens is 3 by 2. As focal length equal to what? 0.3 meters. F air is equal to 0.3 meters. Find the focal length of a lens if it is immersed in a water of refractive index. Mu liquid is equal to what? Mu liquid is equal to 4 by 3. We want to calculate focal length of a lens in a liquid. What is formula for focal length of a lens in a liquid? What we have formula? Here already I told that F liquid is equal to focal length of a lens in air into mu lens minus 1 by mu lens by mu liquid minus 1. From this, F focal length of a lens in air how much? 0.3. Mu lens how much? 3 by 2. 3 by 2 minus 1. 3 by 2 by how much here? 4 by 3 minus 1. From this, here focal length of a lens in a liquid is equal to 0.3. 3 minus 2 by 2 by how much here? 9 by 8. 9 by 8 minus 1. 9 by 8 minus 1. So from this, here 0.3 into 3 minus 2, 1 by 2, 1 by 2 by 9 minus 8, 1 by 8, 2 ones, 2 fours. So 0.3 into 4, how much? 1.2. Focal length increases. Why? It is immersed in a liquid of refractive index how much? 4 by 3. Lesser refractive index. So focal length increases. So what is the answer now? Focal length of a lens, if it is immersed in a water, focal length becomes what? 1.2 meters. A symmetrical double convex lens. A symmetrical double convex lens is cut into two equal parts. Is cut into two equal parts. Cut into two equal parts along a plane. Along a plane perpendicular to the principal axis. Perpendicular to the principal axis. Perpendicular to the principal axis. If the power of the lens is power of the original lens is 4 diopters. Power of the original lens is 4 diopters. Find the power of one of the two pieces. Find the power of the, then find the power of one of the lenses. Power of one of the lenses. One of the lenses. Here, what we have question? A symmetrical double convex lens is cut into two equal parts along a plane perpendicular to the principal axis. Now, this is symmetrical double convex lens is cut into two equal parts along a plane perpendicular to principal axis like this. Perpendicular to principal axis. If the power of the original lens is 4 diopters, find the power of one of the pieces. Power is equal to how much? Initial power 4 diopters. Now power of the one of the pieces like this. Now we want to calculate P1 or P2. Here two are plano convex lenses. If the lens is cut perpendicular to principal axis, at that time what happened? Focal length becomes what? Focal length becomes twice. Focal length becomes twice, already explained. So focal power becomes what? P by 2. How? Here it is plano convex lens. What is focal length of original focal length? P is equal to how much? 1 by f is equal to mu minus 1 into 2 by r. Mu minus 1 into 2 by r. Now P1, P2 becomes what? From this P1 is equal to P2 is equal to 1 by f dash is equal to mu minus 1 into by r. Mu minus 1 into 1 by r. Plano convex lens. So it is nothing but what? Here P1 is equal to, here 1 by f is equal to what? 1 by f dash. 1 by f is equal to what? Mu minus 1 into 2 by r. Now 1 by f dash is equal to how much? Here P1 is equal to P2 is equal to 1 by f dash is equal to what? 2 by f. 2 by f. Here it is nothing but not 2 by f, it is 2f. Here mu minus 1 into r, what is that? Here 1 by f. Here 1 by f dash is equal to what? Mu minus 1 by 2r. Mu minus 1 by 2r. It is nothing but 1 by 2f. 1 by 2f. F is 1 by f how much? Mu minus 1 by 2r. That's why f dash becomes what? 2f. F dash becomes what? 2f. So it is nothing but what? P by 2. P by 2. Remember this. Already in theory already explained. Now P1 is equal to P2 is equal to how much? P by 2. P how much? 4 diopters. So P1 or P2 is equal to what? 4 by 2. What is the answer now? 2 1s, 2 2s. So 2 diopters. You remember this formula. If the lens is cut perpendicular to principal axis, focal length becomes 2f, focal power becomes what? P by 2. If a lens is cut perpendicular to principal axis, focal length becomes 2f, focal power becomes what? P by 2. Focal power becomes P by 2. So what is the answer now? 2 diopters. Actually we have options here: 2 diopters, 3 diopters, 4 diopters, 5 diopters. So what is correct answer now? 2 diopters only. Focal power becomes what? Half of the initial, half of the power of original lens. So what is the answer now? 2 diopters. Now what is given? A double convex lens is made of glass which has refractive index how much? 1.55 for violet rays. So mu v, refractive index for violet rays how much? 1.55 and 1.50 for red rays. Mu r is equal to 1.50. If the focal length of violet rays is 20 centimeters, focal length of violet rays FV is 20 centimeters. Now we want to calculate focal length of red rays. Focal length of red rays. Here you know that this refractive index, here refractive index value is different for what? Different colors of light rays. According to lens maker's formula, we have 1 by f is equal to what? Mu lens minus 1 into 1 by R1 minus 1 by R2. Here radius of curvatures are constants. Double convex lens, so R1, R2 are constants. So what we write now? 1 by f proportional to mu minus 1. 1 by f proportional to what? Mu minus 1. This mu value is different for different colors of light rays. So according to that, here what we write now? Fr by Fv. Fr by Fv is equal to mu v minus 1 by mu r minus 1. Fr by Fv is equal to how much? Mu r by mu v minus 1 by mu r minus 1. Mu v how much? Mu v is 1.55. 1.55 minus 1 by mu r how much? 1.50 minus 1. So from this 1.55 minus 1 how much? 0.55 by 0.5. Fr is equal to Fe how much? Fe is 20. 20 into how much here? 0.5. 5 ones, 5 11s. Here how much here? 1.1. So 1.1. Here 20 into 1.1. So for this point this 0 gets cancelled. 2 11s how much? 22. 22 centimeters. This is the focal length of for red rays. Here you must remember refractive index of a lens is different for different colors of light rays. So refractive index is different, so focal length also different. Inversely proportional. Here for violet color light rays how much? 20 centimeters. For red color light rays what happened? Wavelength is more, refractive index is less. So focal length is more. Refractive index for red rays how much? 22 centimeters. Okay, again you practice, you must thorough in concepts, and after that you must practice all problems, and also in our textbook you practice solved problems. If you are doing solved problems, you are getting idea about problems.